And back with number 4, we have some advertisements going on again, except this time we do have some information about how much it costs to run those advertisements. So a candidate wishes to use a combination of radio and television advertisements in her campaign. Research has shown that a 1-minute spot on television reaches 0.09 million people, and that each 1-minute spot on radio reaches 0.006 million people. The candidate feels she must reach at least 2.16 million people, and she must buy a total of at least 80 minutes of advertisements. So what we've got is we've got to figure out what our totals are. It looks like we need to reach at least 2.16 million people. So we're going to put 2.16 in here. And at least, so it's got to be greater than or equal to 2.16 million. And then we need to we must buy at least 80 minutes of advertisements. And so 80 is what I'll throw in here next. It's got to be greater than or equal to 80 minutes of advertisement. And so let's see, we've got the number of people that we need to reach and the number of minutes of advertisement that we can spend between both TV and radio. And so that is going to be, oops, I want my highlighter, not my pen. That is going to be step 1, everyone. Identify the totals and label them. Step 2, we are going to have I should have left myself some more room here on top. We're going to have some items and some numbers that are associated with them in terms of how many or how much. And so let's go back now and figure out what those items are. So we have research shows that each 1-minute spot on television reaches 0.9 million people. Okay, so TV is going to reach 0.09 million people. We'll call TV our X value. And that each radio spot reaches 0.006 million. So radio, 0.006. And then it looks like we don't have any information about the minutes. And so what we need to assume then is that the number of minutes we don't know. And so we're trying to figure out how many minutes would we spend on TV and how many minutes would we spend on the radio. Just like with the problems about sum of the money plus sum of the money equals all the money, we didn't know how much was invested in each. So we just made it X plus Y. With that, everyone, I'm going to go ahead and put those numbers into GeoGebra and see what we come up with. So again, my 3 bars over here, new, and I've got a new sheet ready to go. So I've got 0.09x plus 0.006y is greater than or equal to, has to be more than 2.16. Then we have x plus y is greater than or equal to 80. So let's zoom out until we find what looks like our solution. Again, I can't move unless I grab the arrow over there. So we have a solution way up here, a solution here, and a solution here. Again, we're looking for the corners that abut the dark purple area. And so to be able to put our points on, we need to duplicate these inputs and put an equal sign in there so that GeoGebra will see that there's a line there. We also need to add a line at x equals 0 and y equals 0 to account for the x and y axes. So to get those points, everyone, I will click my intersect tool up here. I'm going to zoom in on that one and make sure it got the right point. I think it had to because I thought it was like a little bit lower than that just by looking at it, but it looks like it's 360. That's why it's important to use the intersect tool and not just kind of guess using this drop a point tool, because this would not be exact and the intersect tool is. So what we can do now, everyone, is we've got those 3 points. We're going to grab that information, put it on the iPad, and we'll go from there. So my 3 points are 0, 360, That would mean 0 minutes of TV advertisements and 360 minutes of radio advertisements. My next is 2060. 20 minutes of TV and 60 minutes of radio. And my last is 80, 0. 80 minutes of TV and 0 minutes of radio. So there's obviously a gigantic spread here in terms of what's available for us to spend or purchase in terms of how much we can get of TV or radio. And there's obviously going to be a huge difference associated with cost depending on which one of these we do. So let's take a look at our problem again. And we need to recognize that how many minutes of each medium should be used to reach the desired audience while limiting cost as much as possible if television costs $500 per minute and radio costs $100 per minute. So TV, the TV ad is going to be $500 for every minute. So 500x. And the radio is substantially cheaper at 100x. So someone might look at this and say, you know what, I'm just going to buy all radio because it's way cheaper. Well, we're going to do math. We're going to use our points to figure out which one of these is going to be the cheapest. And so again, we're wanting to keep cost as low as possible while still reaching the desired audience. The way that we're going to do that is by creating a cost function. That's not 50x, Schlegel, that's 500x. Plus 100x is going to be what the total cost is of ads spent for both TV and radio. So for point A, we have 0 minutes of TV and 360 minutes of radio. Option B is 20 minutes of radio and 60 minutes of 20 minutes of TV and 60 minutes of radio. Option C is 80 minutes of TV and 0 minutes of radio. So we're going to put each of those in Wolfram, everyone, and see where we end up and see what the most cost-effective option this candidate has for reaching their desired audience. We've got 500 times 0 plus 100 times 360. It's going to give us 36,000. It will cost 36,000 to do the campaign advertisements if that's the plan that we go with. Next, we have a mixture of TV and radio. It's going to cost 16,000 to do that. So again, everyone, a $20,000 reduction in cost, while we would still reach the exact same audience. And then 500 times 80, all of the eggs in the TV basket this time. 100 times 0, we have the most expensive out of all of them, 40,000 with that option. So if this candidate wants to reach the desired audience and do so as cost-effective as possible, option A with 20 minutes of TV ads and 60 minutes of radio ads is the way to go. Let's look at something really quickly in GeoGebra, because again, I run into students all the time that are like, well, what if she did like 50 and 50? Well, if she did 50 and 50, we can see that 50 and 50 would end up in the solution area. So let's test 50 and 50 just to see what would happen. It costs 30,000, again, not cheaper than our cheapest option. And what I'm trying to sort of demonstrate with this is that you are not going to beat one of these 3 points. One of these 3 points is going to be the best solution no matter what. And so you could throw different numbers in, you could do something. There is no way you're going to get costs cheaper than $16,000 for this scenario. And again, someone who is foolish would either just say, hey, let's just run TV ads and spend $40,000 when they could have reached the exact same audience for $24,000 less by doing a mixture of TV and radio to the tune of 20 minutes of TV and 60 minutes of radio. So again, this candidate should purchase $20 minutes of television ads and 60 minutes of radio ads. A terrible way to go about that, everyone, would be, hey, let's just do it and see what happens. If this person just did it and see what happened, they would be spending $24,000 more than they needed to get the exact same result.